Good morning everyone. Today we are going to be looking at compound interest and the formula that you'll use to answer compound interest questions. Alright, so just a quick recap. We did go over this last year, but the two main types of interest that we look at for this topic is simple interest and compound interest. So with simple interest, you have a linear growth rate. So the interest that you earn is the same amount per time period. So for example, every year you might earn $500 interest. With compound interest, it has exponential growth. So you earn a percentage on how much you have. So for example, if you started with $10,000, you might earn 10%. In the first year you might earn 10% of $10,000, which would be 100. So in the second year you would earn 10% on $10,100, and your interest you earn will grow exponentially. Hopefully that makes sense. So we're going to look at the annual compound interest formula. So you will learn two formulas, and I'm going to do a second video for the other one. But this is for compound interest if your interest is compounded annually. So remember, annually means once a year. So let's have a look at this example. Suppose $4,000 is invested at 5% per annum, interest compounded annually. Each year the value of the account increases by 5%. So after 1 year, it would look like this formula here. Let me get this one here. So 4,000 times by 1.05. Now the reason it's 1.05 is because we're increasing by 5%. So we would have 105% because the original amount is our 100% plus the 5. Remember, when we work with decimals, with percentages, we convert it to a decimal. So 105% would look like 1.05. So then after the second year, it would look like your 4,000 times by 1.05 for the first year times by another 1.05 for the second year. And to write that in a simplified version, it would look like this, because if you remember back to our index laws rule, if I had 2 times 2 times 2 times 2, that would be the same as writing 2 to the power of 4. So it's the same concept here. It's 1.05 to the power of 2. And then you'll see a continuation of this. So after 3 years, it would be 4,000 times by 1.05 to the power of 3. All right, so that's sort of showing you why we have the formula that we have. So this here is our formula. FV stands for future value of the investment. So once you do this whole calculation, it'll tell you how much would be in that account. PV stands for your present value, or your original amount. So in that example I just showed you, that would be the 4,000. I is the interest rate as a decimal. So if you had 4.5%, it would be 0.045. The 1 is here to represent your 100%. So when we do 1 plus 0.045, you would get 1.045. So that 1 is just your 100%. And N is your number of years. All right, this always represents years. If you are given a time value not in years, then you have to convert it to years. So write this down, make sure you have it on your cheat sheet, label it if you think it will help you. And I'm going to go through an example. So $2,000 is invested for 6 years at 3.5% per annum, interest compounded annually. What will it amount to at the end of this period? Give your answer to the nearest cent. So I'm using this formula, and then I like to identify all the variables that I have. So my present value would be 2,000. My interest is 3.5, so it would be 0.035, and the number of years is 6. So then all we're going to do is substitute these values in for our formula. So it would look like this. And then you could put this straight into your calculator and that would work fine. I have shown just a further simplified step here, and you would get $2,458.51. So the investment will amount to $2,458.51. So that's part A. Part B of the question says, how much interest will he earn? So we know the present value that he started with and we know the future value. So the difference between those will tell us the interest that is earned. So this is another formula that would be worth adding to your cheat sheet. So present value is 2,000. We know that this was the future value. So when I take the difference, it's $458.51. So I would like you now to go to your textbooks and do question 1 and 2. Pause your video and then come back for the next example. Good luck. Okay, hopefully you were able to do those questions. If you were stuck, just email me and I can send you through some worked examples. Now, there is a variation of this formula as well. So we can rearrange this formula to if we want to find the present value, not the future value. So some questions will ask you to find the present value if they give you the future value. So we'd have to rearrange the equation. So if we look at this as our original equation, we want the present value by itself. So remember, that means we need to move all of this to the left-hand side. Remember, when we are rearranging equations, you do the opposite operation. So the opposite of multiplying is dividing. So we're going to divide both sides by 1 plus I to the power of n. So it would look like this. On this right-hand side, these two are going to cancel out. And then we would be left with this formula here. So if I show you it here a bit bigger, so this is another formula that I would suggest that you write down and put on your cheat sheet. So it's the compound interest formula again, but just rearranged to if you want to find the present value. So let's do an example for this one. Jared invested a sum of money at 6% per annum, interest compounded annually. After 4 years, there was $4,418.67 in the account. How much did Jared invest initially? So the fact that it says that invest initially, that's telling me that I'm looking for my present value. So then I'm going to identify all my other values here. I've changed 6% to 0.06. And then I've substituted them all into my equation, and I get approximately $3,500. So he invested about $3,500 into the account. So that one's pretty easy. You have question 4 and 5 to do for that on page 171. So pause this video, complete those, and then there's one more example that I want to go through with you. Alrighty, the last example that we are going to go through is if you need to rearrange it to find the interest rate. So you may get a question or two that will ask you to find the interest rate if it gives you the present value and the future value. So again, we'd have to rearrange our original equation. So we are trying to get this bit by itself. So we need to be able to remove the present value and we need to be able to remove n. So to start with, we would remove the present value. So we would do that again by dividing both sides by the present value. These two will cancel out. And then I'm just going to rewrite it so that what we're looking for is on the left-hand side. So now we've got 1 plus I to the power of n would be equal to your future value divided by the present value. Then we need to get rid of n. So hopefully you remember that the opposite of squaring something is the square root, and that concept continues on to when it's the power of any number. So say this is to the power of n, so then we would take the nth root, and I'll show you in just a second how you would actually put that in on your calculator. So we're going to take the nth root on both sides. Again, this is going to cancel out, because like when you square something and take the square root, they cancel out. This cancels out here. So then we're left with 1 plus I equals the nth root of the future value divided by the present value. So you've got all your variables here. Now, your answer is 1 plus I. To get that to your interest rate as a decimal form, you would then, once you do this part and get your answer, you would then subtract 1 and then convert your answer back to a percentage by multiplying it by 100. But we're going to do this in the example. So Georgina invested $6,000 in a compound interest account. After 3 years, there was this much in the account. Find the rate of interest paid. So we know that it's this formula. These are our 3 variables. And all I'm going to do is substitute my variables into this equation here like this. So if I did this part here on my calculator, this part here, it would become this. So then my final step would be to subtract 1. So I would get it as 0.043, and then I would convert that by multiplying it by 100. So I would get 4.3%. Now I just quickly want to show you what this would actually look like, how you actually put it in. So you press shift and this button here, and that gets you your root, your nth root value. So hopefully that makes sense to you, and you have 2 questions to complete, and then you're done. Good luck. Let me know if you have any questions. Bye.